Hello everybody, that is an update on Kapanadze device and also on Tesla's Fuelless generator. So I went a little bit more down, dig out a patent Kapanadze did file in 2008, and had also a good look on a video where he and a bunch of other Russians did bury a radiator, car radiator, and used as a second earth line a water tap from the ground. So a couple of things you need to consider in order to get that working. First of all, the system is a serious connection. When the load is connected, the complete system needs to be synchronized to the load. You cannot add or you cannot take add a load, otherwise you will change the frequency of the system and it will not work anymore. That's the first downside. So you need actually to isolate the load. You need to have a translation, you need to have a transformer of some sort, but you cannot draw current from it continuously in a very invariable fashion. You have to use a constant load in order to synchronize with the system. So let me explain here his patent. This patent he did file in 2008. It's on my website under patents, available for you to download. It has a couple of components. So the first is an entry component. So he has his battery, then he has an inverter, just a normal 12-volt inverter. Then he has a control box here. He calls it a switch. Then he has a couple of filters, capacitors, and so on, and it goes into the primary. So what it doesn't show here is that the primary is actually connected to the secondary, so it's on top of each other. So on the secondary has an earth connection, which goes then again into a filter system where the frequency is adjusted, and the frequency goes then to number 11. 11 is a current enhancer. Into 12, again a filter system with capacitors and out to the load. So you have two earth connections. One earth connection from the battery going to the ground. You have a second earth connection going through the secondary out in here. And this is also earth to the ground. So what you see is only one ground here, and actually it's in fact two grounds. So I have made an enhancement now on my system. So I spent a little bit more time and see what I did come up with. First of all, I did spend a great deal of a very efficient grounding system, which is working inside. So you have a center rod here, and then you have on the outside four 6mm copper rods as well. So that is 10mm in the middle. I changed then also the primary. So the primary has his required turns. Course is extended from the secondary. On the other side, this comes out, so I use some plates of copper and so on. And this system is far more efficient. So my measurement for efficiency is how fast can I charge my capacitor, so that's my first trial. And the frequency is a bit lower on this one, but the power going through the system is higher. Let's have a look. So you saw a picture. I haven't started anything at the moment, so it's 1 volt on a capacitor. I would start now as a function generator. It loads it right away up. There is no power at all on the system, so it draws a lot of power already, and there is no power literally into the capacitor. Capacitor is here again, as you see. You have germanium bridge rectifier to the ground, and you have your 200 volt capacitor here. So without me even starting, my little driver here, powered from my little bench power supply, it goes up to 3 volt. Now let's start the power supply. Let's have a look. So that's a tremendous improvement. So it's actually max already. System says 53 volt. 55 volt only after a couple of seconds. So that's 10 times faster than before. It took me about 20-30 seconds or longer before I reached the same power level than before. What do I have here? 6.8 volt and 60 milliamp. So that's also a big achievement by a factor almost of 10. I need far less power to charge it much faster. So that's a very, very efficient system, and the frequency, as you can see, is 1.2 megahertz. Let's have a look here on frequency. So the voltage is approximately the same, but I draw much more current from the earth. Look of the change of the amplitude. So I have my 6 volt, 6 milliamp. And start up. Amplitude goes up. That's 20, that's 30 volt, that's 40 volt. I'm at 50 volt now. Let's spark it down. 30 volt, 40 volt, 50 volt. Five, 6 seconds. 6 volt, 50 milliampere. That's great. Let's see how fast it charges. I charge up now, start now. At 50 I give it a push here. Yeah. It's quite nice. So it charges very, very fast. 6 volt, 50 milliampere. I did also use and tested an NST now and a MOF. It's very, very difficult to start NST because the voltage in the system is too high to be contained. So when you use a load, the contacts of the load have to be quite far away, or you need to transform it down. So I had no luck with any bulbs I used with the NST because the voltage was far too high. It was sparking all over the place. I used them, a couple of them. The sparks went through. So NST is not ideal to use for that system because you have to think about what you do later on when you want to use a load. So you have to transform it down, you have to step it down. There's no way around it. But with a MOF you're within the range of 2000 volts. That's not such a big problem. So let's do it a try where I use a remote switch, a short switch, or yeah, just a little relay switch. You can see at the moment we have 3 volt. I press the button and it goes down to 0. Let's put some lights here. So let's take that as a measurement. But at the moment the function generator is started. 6.6 volt. Let's have a look. Current 50 milliamp. Here you go. 50 milliamp. It does not charge. It does not change at all. I release. I haven't timed it yet, but you can count till 10 probably. 7, 8, 9. I think below 10 seconds and it will be fully charged. And the amazing thing is that has no influence on a current. Continuously charges. And what I realized as well is, even if I increase the power, let's say I put in 30 watt, it does not change anything except that the voltage goes slightly a bit higher, but the charging frequency does not increase. That means we have a complete different balanced system here, which does not rely on current as a factor for charging or for driving a load. So that is interesting, and that's something I have not seen before. So as you can see, 6.6 volt, 5 milliamp. Charge again. And that does not change. It stays at 6.6 and 5 milliamp. 50 milliamp, sorry. It's amazing.